field. And we're taking a tramp into the woods.
I think it's not hard.
Just ski it. We have some all-terrain Jesus boots.
Yes, twice.
No break dancing.
Yeah, I'll go. If I fall on you, can do that. Hold me so good.
Taking a tramp in the woods. Collecting samples. And 34, yeah. Surprise map. Not noted on the list. I guess so. We have an extra lap on it. Yeah.
Down the street here.
Frankie, you okay?
Yep.
Are you walking in the water?
Able to find somewhere else. That's nice. I think that's that. Some representative of our leader? No. That's pretty cool. So what would be some things you'd want to measure? I was part of a, what the heck it was, a Division of Wildlife stream monitoring or river monitoring project here in Colorado, and we did the Gunnison River. And one cool thing that we could do with the tape, I mean, I just want to talk you through some of this stuff, because here would be kind of tricky, but what we would do is, who's got those wooden stakes?
Right here.
Oh, cool. What we could do, now those are in meters, but you could get something similar, and you would actually do what is called a cross-sectional profile of the stream. And so we would figure out the width, and then we'd get out there with our waders and figure out the depth. And then the really fun part is, let's say Frankie would go up by that bridge, and we'd measure it out, and we'd say, we got 30 feet. And then the best part is we'd drop an orange right there, and then we'd time it to here, and what did we just figured out?
Flow rate.
Yeah, the flow rate, and that's a biggie. How much water? Especially in Colorado, that's kind of the land of drought. Alaskans don't even think about water, quantity, or volume. There's always plenty of it. For the record, and it's kind of an unusual rate, but it's CFS. And so that's cubic feet per second. And I was in Costa Rica, and it turned out the guide that was the river guide that I was floating the river with was from Colorado. He'd been up in Summit County and Breckenridge and floating a bunch of rivers and all this. And so I would ask, I said, well, what's the flow rate? And he knew. And it was about 500 CFS. Now this is like 10 or 20. You literally look, and you say, okay, what's the cross section? And somehow you'd have to imagine, maybe 10 to 20 cubic feet. And then in 1 second, it goes by a foot. And I would say that's reasonable.
Yeah.
This thing could kick up a lot more. And it will with runoff, right? So flow rate's a biggie. The things we would look at, probably the most important biological abiotic parameter of the stream or aquatic ecosystem is what, Ramona?
Trees.
No, 2 letters.
Flow rate.
D-O.
Oh.
Dead. Dissolved oxygen.
Okay.
Now, and that's what we'll probably get. Whoever's got that little blue box.
Oh,
And yeah, we'll kick that in the stream. And so you guys we can read the instructions on that. That usually works out pretty good. Hopefully everything's in there. Be a short-lived experiment.
Oh.
Now, what you got to do with this, you got to read this kit. Warning, blah, blah, blah. Who wants to read all that? Now, here we go. So, it's really simple. And, oh good, it's in English. And, so the ticket is this one right here. So this is a brand new kit. The guy who's doing this, and if you're into this sort of thing, or if you have reason to be, his name's Robert Ruffner. Anybody know him? Huh? Big tippy guy? And, actually, he's at the Kenai River Conservation, that real nice building near the airport, down Funny River. Over there. Now, the secret here is we got to fill this thing up. And if we're measuring oxygen in it, right? And what we're going to do is a titration. But first we've got to tie up that oxygen. And so we'll put in 2 reactants. And it's pretty simple. You just open these up here. I don't know, what's this one? Yeah, powder pills. Yeah, so that's one of them, and I think this must be the others.
Yeah, we lost Heather.
Oh, I know that. Waiting around. I gave her her usual 20 minutes, and she's gone. Yeah, now this is number 1, and this is number 2. So it's really simple, and they even give you these giant, what happened to those big clippers? Oh, they're there. And so they'll give you those. And so we got to read the instructions, and we add them to this. Now, you want to make sure this is full of water. Now, ideally, when I did this, and I did this for years down in Colorado. What? Yep. And so the secret is, what water do you want? I mean, they were real nitpicky, yeah, in the middle. And so, and it actually it was horrible. So I came up with this chemistry clamp, and I'd clamp it on so I could stick it in the river, because you'd freeze, but you're a tough Alaskan woman, so. Now, when you get that in, you're going to get it in, I want it full of water, and nothing else.
You want us to put a railing down? If you want a railing, then it's fine.
If she falls in,
There's a log to catch her if she falls.
Yeah, just grab that log if you're going downstream.
that would be the end of the
Had that before. We were
Good golly, don't even put those ideas in there. Sheesh, that'd be horrible.
We were canoeing in Nana up by Fairbanks.
Alright, oh gosh.
Hello.
Who's gonna get that out? This grate might not be so good.
Can you grab it?
Yeah.
Alright, here we go.
We'll have to get something eventually.
You want a stick? Nice skinny arms.
Solve the problem.
Are they long enough?
Not long enough.
Look at that thing. We'll try.
Mm-hmm.
Thanks. Grab the net.
You gonna pull that off? Ooh, she's close. 1 inch, one more inch. Half an inch. We need a stick.
That's all I got.
Yeah, well, we'll kick it over. Alright, so what did we do? Fill, dissolve, we stop it.
Put the thing in there and move it towards you. And I'll get it.
Don't stick it on the stone. Oh, there we go.
Alright. Hold it. I'll get done.
Now don't forget, the water's there.
Yeah.
Alright, so we did that. Now, are you listening? Are you waiting for this?
We're not listening. Look at this. This is intense.
No, we're sampling. Now this time we got to put this in a better place so it doesn't fall out.
Where was it? Your pocket?
Three kimosabi?
You're gonna just hold it? You hold it, I'll put it in your hand. Hey, listen, I knew there was a part, I was forgetting. How long did you hold that under? Oh really? 2 to 3 minutes?
Not yet.
So remember that. Alright, moving on. Incline the bottle, insert, quickly avoid trapping air. Bubbles kick. So what we gotta do is, what I do is I just drop it like this. See? Big deal. Alright. The bubbles come tramp, whatever. Okay. Remove the stopper and then add contents of 1 and 2. Alright, so this is 1.
I know.
Okay, here you go, Daddy. Never pardon this. See? Alright, what you do is use the clippers and clip off a corner and throw the trash back in here. You don't want to leave trash out here. They get all upset. Those 5th graders will yell at me if they find out I'm not going to leave trash. You need a clipper? The trash? Whoa.
Alright.
Whoa. I'm going to get one of these. Alright, Frankie, go here.
Push the thingy out.
Yeah, give me a break. Okay, now if you need clippers, they're there.
Oh yeah.
He finds out.
He's all oxygen too.
Yeah. Alright, add
Like
blah
that.
blah, stopper. Shake bottle vigorously. Okay, I'm ready.
Found it in your top ramen, did you?
Okay. Dirty bubbles? No, because I did perfect. The old drop nothing. Okay. Now you hold this like this. And then as soon as you guys are ready, yeah, you can go ahead. Pour in. Pour it all. All of it. Shake it. Don't be doing that.
What'd you do?
Okay.
Is that it?
Okay. Make sure. Okay. All of it. Cool.
Where am I sticking it?
Anywhere in the bucket. Just so it doesn't get picked up. And then you kind of make sure you get all the water on the side
I
right
can
there.
sit my toes.
Oh, yeah. Never did that. Now, the one thing you do is make sure there's no bubbles. If there's bubbles, what do you think you're going to do to the DO? It's going to increase it. Because the next job is you actually do this. Alright? Now what we're doing is we're tying up the oxygen. Alright? We've put in chemicals. And in AP Chem that I used to teach, we actually did all the chemistry on it. And so what we're going to do is kind of like an iron oxide or something. In fact, you will. You're going to get these little floaters in here. And so we just kind of keep doing this for a while until so we read the instructions. It's been a while. Shake bottle vigorously. Fluctuant precipitate will form. Notice brownish orange precipitate indicates oxygen's present. Well, that's fortunate. Otherwise, fish would be dead. Wait for flock to settle. Yeah, now so I do this for a while, and then it's got to settle to that line. So we just kind of space out, and we can hang. So who's got the
Right behind you.
Right behind you. Right here.
Oh, cool.
Where's the fish trap?
You want to see it more?
Yep, let's stick it in the water.
I'll say stick it in the grating, you don't have to
Now
hold
you
it.
could look real quick. Oh, we passed it. It's on the barrel. Yeah. Look, no. Look, wait. What's the air temperature? 10? All right. So that's what? 20 Celsius. Yeah.
Drop in?
No, don't drop anything. Just stick it in the water. Well, you could do that, I guess. But no, put it in the bottom one. So it's in there. Good job.
Alright.
I mean, you still owe me 2 minutes in the water. That's what I remember. I tell you, you hold your hand underwater for 2 minutes, and it's just like, ah! So we would do this on the Johnson all the time.
Open up?
You better.
Say zero's freezing.
Well, it could. If I was to guess, it's 2 or 3, but that'd be my guess. So what do you think? Are we at a... Oh, look. Okay, so it's settled out, right?
Yeah.
So you do that, and then you got to do this again. And then we turn the page.
Can I take out the
And it settles again. Yeah, go ahead. That reads instantaneously, by the way. And when it settles, we'll add the third bucket. What is it?
0.
Oh. No, it's above.
Oh, now if you're touching it.
No.
1.
No. One. And I bet,
Give it back.
I used to have a different thermometer in this, but I don't know, it must have been a different kit. Alright, so that's pretty cool. The data's all messed up here. So here we go. This must be why we needed the tweezers. I knew there was something we needed these tweezers for. So it's a good thing we brought those wood things.
Can I take the cord sample?
Yeah, I know. Everybody wants to do that. That's always fun.
Let's all take one home.
Why do they
killed
put
8
scissors
trees.
in there? They give you fingernails. They were 15 years old babies.
Oh, they're easier.
Smart way to do it.
Are they?
Take it off
Yeah.
different places.
Yeah,
but then they're all gonna be the same age. We want diversity. That's so fun.
Alright. Oh, cool. Now, so there's the parchment. So now we gotta dissolve it. Here, hold that. Pull this out. Damn it. All that in. Right in. I've got one. Now this is easy. Wait till you're out here doing these stupid samples of rain and snow. Well, what Robert is trying to do, I tried, ooh, here's bad bubble. No good. Yes, still good at this. What they were doing in Colorado, and what he's trying to do up here is we got to get baseline data. And all the streams in the United States don't have it. And so what is baseline data? What was one of the biggest problems with the Exxon oil spill in '89? They had no data. I mean, we knew critters died. We had a pretty good idea bad things happened to beaches and all that. But there was no data. And if you can't say, well, I counted this many caddisfly larvae for 14 springs before the spill, how am I going to know the biological impact on this stream? Or what were some of the chemical factors? So essentially we do this until it all dissolves. Now if it doesn't all dissolve, that means there's a lot of crap in the water. And up here on the peninsula, what do you know is in that water?
Iron.
Iron, yeah, I was going to say. Iron and more iron. We will not die for the lack of iron on the peninsula. Yep. So we'll let that go a little bit longer and then we'll do the great titration. Drink the water. Alright, we did that, then we fill it up. Now, fill it up to the top.
Maybe we can bottle it and sell it down below. It's a health measure.
Alright, cool. Now, you got something right with it? Alright, so what we're going to do is a titration. So chem students, you want to tell us what that is?
We're finding the endpoint of the reaction.
Right, we're finding an endpoint. And you got to do with a titration, with fluids, how do we get to moles?
Well, you times it by...
Well, with mass, you've got grams, and you know the molar mass of the substance, and so you get the moles and atoms in a heartbeat. With fluids, you got to have volume and concentration. Now, we know the concentration of this. Why? Because we added fixed quantities of reagents to a fixed volume, right? And so, like I said, I've done all the chemistry once upon a time. Now what's fun about this is all you do is you just fill this thing up to the very top like that. And it's perfect. You can't mess this up. Hold up for a second. And you never throw this away because if we screw up the titration, and I might let you guys do this. This is kind of fun.
Not a shooter, Nathan.
Alright, and then we put it in here. What are you doing? Oh, shoot it. That'd be good. Okay.
I thought somebody was meant to alcohol one.
They're pretty dead. I don't think I did it.
Yeah. Yeah, I think they were dead.
Alright,
I
now,
won't kill you.
here's the...
Change your sinuses.
What kind of alcohol?
not do.
Alright.
All it's like it's not about that.
Contrary to popular cultural perspective.
Yeah. Now, what they do here is they're going with milliliters. See, I'm not even reading their stupid thing. But this is exactly, and it's really nice. The bottom of the meniscus is 1.0 milliliter. This line is 0.5 milliliters. Now, but I never did it that way. Quite often in chemistry what we do is you'd actually calculate the volume of a drop. Now the way you do this, and so you get a count, we've done titrations, didn't we? Didn't we do a DO?
We just did a pre-manganate. Drop it till it comes to the...
Well, that's what this is. This is permanganate. Yeah, this is your favorite equation in here, wasn't it? Oh. All right, now count the drops, all right? So you go 1, 2, 3, 4. Now you should swirl, right? But if you don't swirl, you go too fast. You still counting?
Yep.
6, 7, 8, 9. Getting close now.
What's it gonna do?
Change.
It's
Clear.
supposed to go clear.
One more.
11.
Oh, and this is a really good time to do this, by the way.
Oh.
So you gotta make sure.
I can't count now.
Well. Oh, is that it?
Oh, yeah.
You think? Alright, let's do one more. What do you think?
Yeah.
Yeah, that's definitely it, right?
13.
So 13.
13 drops.
So that was perfect. See, that was good titration. Alright. So, shall we just repeat the whole thing?
Really?
See if you guys do it?
I want it.
Yeah. So,
I'm gonna set up the other one.
turn off the camera. Cut! Cut! Alright, let's see if you guys can do it. Of course, knowing the outcome is always handy.
Hey, just go straight to 12 real quick and add one more drop. Hold on a second.
Oops. Now it's a weathered lab book.
Yeah.
Like, one more to 12. Oh. It's done.
Alright, you ready? I'll let you hold it.
You do it?
I'm trying to do it. Put it on here.
You see, I did drops. We ought to correlate here, get to a full, and then we ought to see how many milliliters it was. So this time before. Yeah, swirl. See. Okay, wait till he swirls. Swirl. That's 11. See, that looks pretty clear. And what do we do? We stopped at 12?
No.
Yeah.
Now the 25 drops in milliliter though, so it's still the
I don't know. Well, here, let's see. What do we got?
Quarter.
So, quarter. Yeah, is that your call? So 3/4 of a mil. So put 0.75 mils. But that was definitely, see, and I was kind of suspicious. Now, in Colorado when we did this, we would have to do titrations until we were within 1 drop. So in my book, see that was, what did we decide, 13 on the first one?
Yeah, 13 to 12.
And this was, what, 11, 12?
I think 11 it was.
So if you fudge them both to 12 and call it a day, I don't know. Yeah. But anyway, I think you get the point of it. Now, we can go back. We'll do the math when we get back. That's the fun part. And Anyway, ideally, if you're really environmentally minded about this whole business, you bring what is called a waste bucket.
Something we didn't bring.
Which we didn't bring.
Somebody's waste pockets.
And what we would do is we actually just, what I did in Colorado is we kept a water bottle, and it was just said wastewater on it, and that way we did with that. Now let's give this my guess. Any guesses on what the DO is? Does anybody know what?
Final reference?
Yeah.
Probably less than 20%.
Oh.
I was gonna say like 35, 40. 95%? 95. Yeah.
Well, first of all, I don't know if you're familiar with your chemistry or whatever, but what affects the ability of a gas to dissolve in a fluid? And I'll give you a hint. Think of your, pressure's 1. But pressure's probably fairly constant. 1 atmosphere. So,
Temperature.
that's done. Ooh, temps big. We know that when we leave that Coke or us older ones, you know, you leave that carbonated beverage out. As it warms up, the gases bubble out. So temp's going to be a biggie. Now, what was our temp?
1.
It was like, low. And I don't know if you picked up on that, but colder water holds more oxygen. All right. In Colorado, that was a huge issue. If there's going to be trout, it was it. If you got down to the Platte, Denver, anywhere where it warmed up, you didn't have trout. Now up here in Alaska, it's all kind of constantly frozen up here, so that's not as much of an issue. Maybe in Fairbanks it is, but Colorado you had literally cold water streams and warm water streams, and the biggest defining factor was the dissolved oxygen. One more factor. What were we cautious about in our analysis? Air bubbles. Hear anything?
Yeah, variation.
Yeah, and so that is, usually called turbulence, maybe, turbidity, I think that's it. And so we have a fairly young, fast-moving stream, and I don't know if you ever noticed that big culvert that, this is coming from that culvert where across the road, and there's all sorts of water splashing up. And so my guess is between the turbulence and the temperature, we're going to be close to saturation, 100% literally. In fact, when we do the math, we can go back and we'll look at the little book and table and all
And we
that.
still have the sample.
And I'm putting money. Yeah, we do. Now the good news is it's fixed.
The temperature.
Yeah, but we can take the temperature, and this is something we used to do. If conditions were nightmarish, not lovely like now, we would just grab the samples and head back to school, which was 12 miles from the river, and then do all our chemistry. So if you get pills 1 and 2 into it, you fix the oxygen. Remember, it's tied up in that fluctuant.
Right.
So there is a temperature correction factor in the math. And so we just say, okay, the water's heated up to a whopping 2 or 3 Celsius, big deal. So we just figure that into our math, and you can do it. And it used to be this double bar thing, you just drew a line. And temperature was one of them, and drops was on the other one. We drew a line, and we figured it out. So that was pretty cool. Now, what are we going to look for with pH? Any guesses? Why? It probably is.
Hydrogen ions.
So let's see if we can make this thing work. It'll be fun. Has anybody played with this?
Oh.
Yes? No?
No, we have them in the lab.
You don't? Well, I was hoping maybe you had, because I stole them from Frankie.
Market hunters do stuff like that.
What do you mean they go?
I'm playing here.
Not everybody's
No,
true?
not yours.
Well, anyway, what we want to do is, this one's a kind of nice one. I use those red ones with batteries, but the points always salt up. And I didn't even want to get mine out of the kit for a one-time use, because then you got to spend all this time cleaning it. Oh, there. So you put it across the bridge there. I don't know if you can tell. Here, I'll put 2 inches in there too. And so there it is. Oh, look, and it's working. 6.5. Oh wait, I gotta hit a button. Hold this. Yeah, I point number.
pH, so this is water.
No, it's a buffer. Yeah, you remember that. I'm doing that starting tomorrow or next week. So, anyway, what we've done is we've had a buffer solution that stays at 7 pH, so it's dead neutral. And I hit this one button. Am I supposed to hold it for a while? Yeah. We'll read the instructions later. This should kick up to 7. Yeah, we're calibrated. Here, why don't you hold this? Maybe we gotta read the instructions.
What's going on?
Yeah, but it's not 7. It'll take a month. All right, we did that. Decrease. Okay, I did that. We'll flash until stable reading is obtained. Is it flashing? Did the cal thing come on? Oh, here, let me press it. Oh, right. You gotta press it. Yeah, 1. You see it? Yeah, okay. All right. So we'll assume that's that. Then we do.
Let's talk to you, maybe?
No, don't do that. Oh, well, this doesn't even tell you to go to a different cal. Oh, but what up? You did? 6.8. That's cool. Good.
6.8, dang.
Yeah, we might just remember that. Yeah, I always like to do the acid. Right. What?
Just water.
Whoa, there's the problem. Alright. Yeah.
Oh, look at the
Where'd he go?
Not much out to tell you give us a good grade.
Alright. We'll have a good review on Tuesday. Yeah, it makes you tough. Pretty tough.
I'm already tough. Huh? I'm tough enough already.
Kind of chewy and so.
No, it's right on the money. Right
Well
in front of it.
seasoned.
Well,
so.
yeah.
Look at that. Perfect. 4, 1, 0.
Oh, 3.9.
Okay. Alright.
Details.
So what's your guess on the water?
6
Is that 6.5?
Yeah, there, 6.5, 6.1,
6.2 and a half.
5.3.
5.3? Why?
Let's look in the orange juice.
Really?
I don't know.
6.
Well, vinegar is
6.5.
Vinegar's 2?
6.5.
6.5. Now why is it 6.5?
Lower than neutral.
Ooh, look at that. Am I good or what? 6.6.
pH.
Why? So is that slightly what?
It's
Good.
really
And why?
any hydrogen
No
ions.
bacteria in there.
No.
The soil.
Yeah, maybe. You're on the right track. Keep going. Okay.
Pollution.
Anything?
That's good. So, I mean, usually students are sort of conditioned.
Or pollution for the college.
What did he say? Something horrible?
Boreal environment.
Ooh, yeah, that would be gross.
That's what my hand is.
Yeah, but not very long. Not very long.
We'll get in.
Yeah, so where's the acidity coming from? Is this acid rain we're all, blame the power company?
No.
Oh, there is no power company. No, there's no acid deposition up here. Humic acid. And conifers are notorious for that. So needles will always make lots of humic acid. Okay? So the last thing we could do, if you want to give it a try, is you want to see if we can get some critters? I don't think we want to put anybody in the water. I think probably the best thing we could do is stick the net in and see if something happens. It looks pretty deep.
Dive in.
We gotta get this thing out of the
Well,
water.
we'll stick the net over there. And we'll take one of the big long sticks and shove them.
Yeah, we can, if you want. You gonna do that? You think you can even reach?
I don't know, we can reach.
Or you could stand, well that's pretty far upstream.
Oh, fine. Here, hold that.
Well, I was thinking, why don't we just...
Climb on the log.
Ooh.
Right in the middle walk. Are you barefoot? What on earth?
Take my
That is
sunglasses
good
actually,
picture,
now that I think about it.
How
Ooh.
much did you pay for those? Too much. Alright. I think it's
Alright. Balance and coordination.
Yeah, okay, perfect. And what you do? Oh yeah, this might actually work. So ideally you just kind of, oh there you go.
I just want to.
Try knocking off rocks. And,
I think one just got hit in there.
yeah, well, that's okay. Yeah, watch out. That's not bad. Let's photograph. Be careful though. We may actually have some critters in there. So we'll look at that later. We'll just haul that up. Find the bugs later.
Take your coat back.
Good.
No, you have to be breathing.
Actually, I'm not.
So I'm really sick. I don't know why. Oh man, it's on me.
What's wrong?
Baby mama. That's what it was.
Alright. Nice young guys.
I
know.
Watch out.
But
Oh, sticking out stuff.
I know, but the quick.
Heave! Up with the drawbridge!
There you got it. Cool. Now we've done some. Sometimes we'd actually do alkalinity in the West. That's a huge issue. We've got a lot of salts coming off the soils. In Mexico, we talk about illegal immigration and drugs. And Mexico will throw one thing at the U.S. face every time, and that is the salinity of the Colorado and Rio Grande rivers is saltier than the Pacific Ocean. What is that?
No.
Oh, so those would be some other abiotic things you'd maybe look at. Now, and this kind of segues into what we're going to do next. The other thing you would do, though, is you would kind of take a look, and what other comments would you make about this stream? Oh, and the weather would be one. You could say, very common, you would say overcast.
With snow.
Yeah. Scattered snow, rain, whatever.
Temperature what? 38?
Yeah,
10 degrees
something like
Celsius.
that.
Done butt candy.
So, 42.
You gotta hold on to that. That's $200. Couldn't believe it, dropped it twice.
Yeah, stay away from my sunglasses.
Yeah.
Okay, let's go.
No. What do you guys haven't told me anything about this stream? So what do you see?
Color.
Ooh, color is a very good one.
Isn't that aspen?
It's that it's humus. You know, you got a lot of leaf litter, whatever. And what else do you see in there? Okay, good.
Silt.
Maybe. You see the foam? Foam's a biggie, too. I've seen some streams, there's oh wow, what's going on? It looks like root beer floats. And it's that humic acid will really froth up. The other thing you want to talk about, and you're about done with the aquatic assessment, is what kind of cover. Yeah, not right now you would say, well, it's winter time, but in the summertime there would be some shading, right?
A lot of
Yeah. And that's a huge factor, especially on fish-bearing streams. Huge interface with logging. One of the things we found with logging is they add sediment and remove shade. So with that, why don't we start working our way back? So who's grabbing what? Spider.
Somebody can grab the critters.
Everybody's got to grab the critters. I'll grab
the
this.
critters like.
18, I went up to Snow Cave in Roomville.
So where's that fish trap?
Oh, yeah, here's the fish trap. Wait, it's gone.
It's gone.
That's a bummer.
Trap pirates.
The rope was right here. Yeah, weird. Huh.
Okay, somebody was hungry.
Yeah.
Was it just one of those little conical ones with the...
Yeah, exactly.
With like a minnow trap?
Well, a cylinder, and then it had a cone that came in with a hole, and then there was fish eggs in there.
Minnow trap.
Yeah.
Yeah.
And my son, I kind of laughed at it when I saw it, but my son told me, he said, sometimes there's millions of them. Oh, what's that? Did they move it? Is that the fish trap? Oh my God. What's that? I don't know.
It might have been very pull it out. We don't know what it is.
Oh, it's a bowl in the ground. What they could do is they might put instrumentation in.
Right.
And then when it's frozen, and that's probably just so it's a level.
Oh look, a spiked tree.
And what they could do is sometimes they'll put levels, yeah, see this is a whole station of somebody. So yeah, what do you guys notice here? Yeah, and these are, I don't know if you can tell, but see, these are actually from woodpeckers going after the beetles, all these little holes here. Now these real small holes are the beetles coming out. So that would be the bark beetle. This kill is quite a few years old. Generally it's called flagging when they first turn red. It takes 2 years for them to lose the needles. So this is at least 2 to 3 years old. Now, I mentioned earlier, the peninsula is changing biomes as we speak. And why? You can see evidence here. Well, yeah, the beetles kill a tree, but usually the tree will fall over, create that mineral soil, and you can get regen. Why aren't we seeing that? What's the difference? Exactly. Look at that stump, and look at the one behind you. We're getting a phenomenon known as break-off, and this one's just classic, the rot. Well, when that breaks off,
Bodies next to it.
yeah, and you can see the fungus, all the rot in it. When it breaks off, notice what's intact, all that grass. And so literally the peninsula is turning into a grass site, a meadow-like. Will moose populations decline? More than likely. Caribou increase? Maybe, you know. So that's another one that we'll see. Yeah, the lack of food. We didn't bring that. Did we bring that ice tray?
Skiing. Just like cross-country gear.
Guys are hardy. Jen, you gotta hold up right there. Alright. Now, this is a lot of times we say, well, how are we going to figure out what's happening out here? And so I had this, and it has several knots on it because it would stretch out. So my distance, which you guys will figure out when you get back to that. 11 feet. This one, yeah. Oh, you did figure it? Or do you remember? 11 point what? But that's decimal. So then you take 0.78 times 12 inches. And it's when I think about it, you did 11.78. That's decimal feet. So it's 11 inches, it's 9 inches. So 11 feet, 9 inch radius. So we'll just randomly, so there you go. And we'll just, it's the knot, so that gives him something to hold on to. Now with two people, it works pretty great. So what you would do is you'd go around, let's just switch this way. All right, now with that in, you got to look down. What was that? That was that. All right. Yeah. So what is that? You know? It's a shrub. Yeah. So shrubbery one. All right. Whoa, 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 whoa. Now what do we got here? That's great. Well, that's exactly that. And that's when it gets fun. So you've got 3 stems of Picea. This is that black spruce. No, there's more than that. Well, I see 1, 2. Isn't there just one there? What is that? One coming out right there. Where? Right now. Oh, that's dead. It's deader now. So 4. So 5.
You're like, careful, Jimmy!
Okay. 5. Who's beeping?
Me, it's time for me to run away.
Oh, really?
Yeah.
Well, yeah, you have to do your class. How you doing?
Okay.
Now,
Well, good people, I should take my leave of you.
What do you got? 4, 5, 7, 8. So you're gonna go up.
Are you writing this stuff down? Yeah. Can I get some stats?
She
Thank you. Yeah. Okay, I got your promise on that. Right?
Yeah.
Okay. We'll see how you foresters later.